Hello. This is the third method of apportionment we're talking about, and it is called Webster's method. Okay. Very similar to Jefferson's method with a slight tweak with it's about in the other ones we use the lower quota, and then that was like our beginning. This one, you don't just do the lower quota, you actually round in the conventional way to the nearest whole number. So everything else is pretty much the same, especially the same as the previous one, Jefferson's method, where you still have a modified divisor and you might have to do it more than once. But in this case, right, you start the same way. You determine the standard divisor by taking total population divided by total number of representatives. Then you decide each state's quota by taking the state's population and divided by the standard divisor, right? And then with Webster's method, you just round those numbers to the nearest whole number, right? Don't forget the decimals. I mean, you never want to forget the decimals, right? But you round them all up. And so you'll have these, I don't know, rounded quotas. That's what I would call them, the rounded quota, right? Then you add those all up, right? If that number, of course, if that number equals the number of representatives, you're done, right? But if that number is less than the total number of representatives that you need to allocate, you make your divisor a little bit smaller, right? Reduce it, recalculate the quota, and see what happens, right? Now, because we're rounding in the conventional way, which means some numbers are going to be rounded down and some of them are going to be rounded up, it's possible that you might get a number when you add up all those rounded quotas, you might get a number that's larger than your total number of representatives. So if that's the case, then you would increase the divisor, so make the divisor a little bit bigger, and that would bring all the quotas down a little bit, and then you should have a lower number. Okay, and you continue doing that as many times as you need until the sum of the rounded quotas is equal to the number of representatives. Okay. So I'm just going to write this down. I'm calling what you get in step 3, I'm calling these rounded quotas. I think that's a good name, don't you think? So we've got all these words, right? We've got the standard divisor, which we know what that is. We've got the quota, which is what you get first. Then we got the rounded quotas. And then if needed, you might need a modified divisor. If your rounded quotas don't give you the right amount, you have to modify that divisor and try again. All right, so we're going to apply this method, Webster's method, to the same example that we did for Hamilton's method, which I corrected, by the way, and posted as an announcement on Canvas, and Jefferson's method. So same 5 states in the small country, same number of seats, same population for each state. But now we're going to do Webster's method. Okay, so let's just write down, see if we can remember. If you recall, because we have the same total population, right? Because if we didn't know that, we would just add up all these populations, right? You just take, right? We have the population for each state. All the states make up the country. So the total population for the country is the sum of all the populations for the states. But since this is the same example we've already done a couple times, we know that the total population is 2,380,000. That's what you get if you add all these together. Okay. And then remember that the seats, we have 119 of them, which would mean that the standard divisor is equal to, if you remember, it's always the total population divided by the number of seats. Can I write the standard divisor? So the SD in this case is standard divisor. So it's a division, it's the total pop divided by the number of seats, right? And for us, that's 20,000, right? That would be 2,380,000 divided by 119. Yeah, okay. But this, no matter what example you're doing, right, you always find the total population by adding up the population of the states if you're not given it already. You have to know the number of seats, and you always find the divisor or the standard divisor by taking that total population divided by the number of seats. So notice, if you want to think in terms of units here, right, like total population is people. So this is like people, right? And then seats down here. So this 20,000 is actually in units. You could think about it as, right, people per seat. And that's what the standard divisor is telling us. It's like, we're saying, given the population that we have and the number of seats we have to apportion, right, each seat should represent about 20,000 people. So if you notice though, right, with the first method, Hamilton's method, that divisor never changed. So, well, it didn't change in our calculations technically, right? Because we then altered those numbers a little bit. Like if you really went and you reverse engineered, like, okay, so say we gave a state with a certain population, a certain number of seats, right? Then you could re-engineer how many people each of those seats actually represents, which might be a little bit different, right, than the actual divisor. But that's why it's the standard divisor. Like given all things, right, each representative should represent 20,000 people. So every seat should represent 20,000 people. It, changes a little bit because the methods and the numbers aren't perfect. Okay, so we've got all that stuff. We got our standard divisor right here, 20,000. That's where we're going to start. Okay, so we did all that. We've got our standard divisor. Okay, so we need the quotas from each state. And we've actually done that multiple times, but I'm going to write them down again here. So let's see. When I fixed my error in the Hamilton's method, I used Excel to do it, and man, that was nice. So if you know how to use Excel, it's actually a really nice way to kind of organize this information, and you can put in the little formulas and it does all the calculations and you can kind of do it really fast. It was really nice. If you'd like me to make a video of doing it that way, I'd be happy to show you. If you know how to use Excel, it's really not easy at all. I mean, it's not easy at all. It's not hard at all. All right, so let's see. I want what I think I've been calling the standard quotas, but I'll just call them the quotas. Okay, so we want to look at that's an A. Quotas. Quotas. Okay, so we have state A, state B, state C, state D, and state E. And if you remember, right, the quota is always the state's population. I'm going to write this down just in case you forgot. The state population divided by the standard divisor, right? That's how you find the standard, or what I like to call the standard quota, because it's the first quota you get, right? Using the standard divisor, you get that first quota, because if you have to modify the divisor, you're going to get another different quota, right? Which is a modified quota, even though those words usually aren't necessarily listed. Okay, so we've actually calculated these a number of times, but let's just do it one more time, because we are actually doing, right, 810,000 divided by 20,000. So that's 40.5. Right, and you might be thinking, wait a minute, you didn't. Hold on, I'm going to make this stay in the front. You're like, that's not 810,000 divided by 20,000. Well, it kind of is, because 810,000 divided by 20,000, right? They're both multiples of 1,000. So I just basically divided them both by 1,000 before I did the division, and it's the same. Okay. And I can do that with this one because they both have those 3 zeros at the end, right? If you were dividing, right, 810,000 by 20,000, right? These 3 zeros each represent a factor of 1,000. And so we can like kind of reduce the fraction or simplify the fraction before we divide. I guess in this case, we could have even done it by more. They actually share 4 zeros. So we could have done 81 divided by 2, not 881, 81 divided by 2, and you get the same answer. Okay. So the quota for state B is the 473,000 divided by the 20. What? See me not using I don't know if it's just 23.65, and I believe that is the same. These should all be, these numbers should be familiar, right? There's 292 divided by 20, 14.6. That's the one I had the error on the first time. 594, not 597, 594 divided by 20, 29.7. And 211, see that? 211 divided by 20, 10.55. And I think that is correct. I'm just checking, yeah, 10.55, 14.6, 29.7, 23.65. Okay. Good, good, good. Okay, so pretty good. So that's how we did that. We take each state's population, we divide by the standard divisor. That's our standard quota. Okay, so then once we have those quotas, what do we do in this method? Oh, we round them all. Okay. Okay, yeah, see, that's why I like to call it, like, that's the standard quota. Then we're going to get the rounded quota. Then we might get another rounded quota for a modified divisor if we don't have the right? So let's just round them all. I'm just going to do a little, Now here we're rounding conventionally, right? We're not just dropping the decimal parts, right? Because when you just drop the decimal parts, you're in essence just rounding them all down to the nearest whole number. This method, Webster's method, says round them conventionally, right? So like 40.5, right? Is that closer to 40 or 41? It's actually closer to 41. So that one gets rounded to 41. 23.65. So, right, we want to round to the nearest whole number. That's the one spot. So you always look at the number to the right. If that number is 5 or above, then the number your rounding digit goes up. So 23.65 is closer to 24. 14.6 is closer to 15. 29.7 is closer to 30 than it is to 29, and 10.55 is closer to 11 than it is to 10. Okay. So that's rounded. I'm going to call that rounded quota, just RQ. Okay, now what is the sum? If we add those all up, what do we get? Let's see. 41 plus 24 plus 15 plus 30 plus 11. So 41, 24, 15, 30, 11. 121. Okay, so we're too big, right? We only had 119 seats. We've allocated 121. So what is that? 2 extra? 20, 21. Okay, so that's not good. We have too much. All right, if we go back to, if we can't remember what to do, right? If the total number from step 3 was larger, than the total number of representatives, then you increase the divisor. Oh yeah, because we know that if you have a fraction and you have some fixed number up here, right? Some fixed number up here, if you increase the denominator, so if you increase the number you're dividing by, you make that bigger, you're going to decrease the overall number. Okay, so if you need to make your number smaller, you have to use a larger divisor. Okay, so we were using 20,000 as the divisor. We need to make a bigger one. All right, so what do you want to do? Next step, we're going to do a modified divisor. Quotas with modified divisor 1, and we're calling it 1 because we might have to do it more than once. Actually, try and give myself just a little more room, because if we have to do it again, modified divisor 1. All right, so we need to go up. So let's do 2,500. Right, that seems reasonable to me. Like if you wanted to hop up to 21,000, feel free, right? See what happens. I wouldn't want to, like, I mean, if you increased it by 1, say you did 20,001, that's probably not enough to change these numbers significantly enough to make any difference, right? But then, if you increased it by like 10,000, I feel like that might be too much, right? So 20,000, like 500 seems like a reasonable amount to me. And that's kind of what the book does in general, right? But like I said, try it. If you want to try something, if you think, oh, I want to try 22,000, try it, see what happens. Nothing wrong with that. I'm going to try 20,500. So just 500 more than the divisor we used last time, right? So now we're going to do the same thing we did before. We got to find new quotas, right? We're going to divide each state's population by this new divisor, 20,500. Let's do it. So the new quota for state A, so state A's population is 810,000 divided by 20,500. Ooh, 39 points. So that has definitely gone down. Now when we round that one, it's going to round up to 40. Okay, let's see. So I'm going to use just 3 decimal places again. 39 point. Actually, I'm just going to use 2 because we're going to round these. We're going to round these to the nearest whole number. So having 2 decimal places, I think, is more than enough. That is enough information to round to the whole number without having any compounded rounding error, without like rounding, because if you're doing calculations and you round, if you have a whole sequence of calculations you have to do, and you round multiple times in between, you can get what's called a compounded rounding error, right? Like if you round too much and then you use that rounded number to do more calculations, then the error that you created when you rounded, which is always and there's always an error, quote unquote error, created when you round, because you're approximating the number when you round, so it's no longer the right number. So there's always some little error there between the real number and the rounded number. But if you use a rounded number and then you do a bunch of calculations with it, then the rounding that you did sort of gets amplified. So, but here, since the only next step we're going to do here is we're going to just conventionally round these numbers. 2 decimal places is more than enough to do that without compounding anything. It's not, right? If you show 2 decimal places and then you round to the nearest whole number, that is not compounding any rounding. You don't get any amplified errors. So. All right, so then let's do state B. State B's population was 473,000. I'm just using all the zeros now, even though some of them could be dropped, 2 of them could be dropped, but divided by 20,500. Make sure I don't make any errors. Okay, so that's 23.07. And I know when we round that one, it's going to go down to 23, and so that's already the 2. So let's see, we might have to do this again if some of these also change. Now, if they all go down, then we're going to have too few, right? But if some go down and some go up and they balance, that's nice. Okay, so let's do state C is the 292,000 divided by 20,500, 14.24. All right, what about D? That's 594,000 divided by the new divisor, which is 20,500. 28.975, so that's 28.98. Okay, that's going to go up to 29. Let's see. And state E, that was 211,000 divided by 20,500. All right, and that is 10.29. Okay, now we want to round each of these, right? I'm going to round. So, and conventionally round. So 39.51, that rounds up to 40. This one goes down to 23. This one is 14. This one is 29, and this one is 10. All right, what is that? Not 440, 40 plus 23 plus 14 plus not 26. I have a problem with those 6s and those 9s. Plus 10, 116. Oh, now we're too low. Okay, so I increased my divisor too much. Right now, my quotas are too small with the conventional rounding. Okay, so we got to do it again. And so now I'm going to do, this is now going to be quotas with modified divisor 2. So I need a divisor that's less than 20,500, but still more than 20,000. So let me go right in the middle. 20,250. What do you think? That seems reasonable. 116 is 3 less than 119. 121 is 2 more. I mean, if you really wanted to do something like, Cassidy, which one's closer? 121 is closer to 119 than 116. So should I go closer to 20,000 than 20,000? Maybe I should do 2,200. I don't know. I kind of want to just go right in the middle, see if it works. But like I said, like there's no, like, there should be a range of modified quotas that will work, right? So it's not like if I choose 20,250, right, and it works, it's not like that's the only one that would work, right? There should be a little range of quotas, modified divisors that will give you quotas that will work. So don't worry about, like, you know, there's not like one number you have to narrow it down to. There's, like I said, there should be a range. So I'm going to do 20,250. I have no idea if this is a good choice because maybe I'll need to make it a little bit smaller, but I'm going to do it here. So now we have to calculate again, quotas again. So for all the states, A, B, C, D, E. All right, I'm going to just slide this over so I can also show the calculator. All right, so we're going to do, again, the populations. Now I don't know the populations. So state A is 810,000. All right, I'm doing 20,250. Ooh, exactly 40. Looky there. So now that one already is rounded to the nearest whole number. Okay. Well, states B population is 473,000 divided by 20,250. All right, 23.358, 23.36. All right, state C is 292,000 divided by 20,250, 14.42. That looks weird. 14.42. All right, state D is 594,000 divided by 20,250. That's my new modified divisor. 29 followed by infinitely many threes. Okay. 211,000 divided by 20,250. 10.42. Okay. Whoa. All right, so now we're going to round these. So 40 stays 40. 23.36 rounds down to 23 because of the 3. That's 14. That's 29, and that's 10. Now, I was going to say, is that the same list we had before? No, it is not. So let's see. If we add these together, what do we get? 40 plus 23 plus 14 plus 29 plus 10. Dang it. So they went up and down in the same. Wait, that's the same apportionment as the other one. Nothing changed? I didn't even notice that as I was doing it. Nothing changed. Oh, so that means I didn't go small enough. Right? I need to go smaller. So what I said to myself, like, maybe I should go a little closer to 20,000 because 121 is closer to 119 than that is. So I didn't go small enough. Right? So that gives me the exact same apportionment. Okay, so I got to do it again. I got to do it one more time. Now I want to, I guess I could just be scrolling. Okay, so I'm going to do it again. I need quotas with modified divisor 3. And now I'm going to go. Now I'm like, should I go like 2,100 or should I do 2,200? Maybe I should do 2,150. Let's see. So for A's population was 810,000. 810,000 divided by 20,150. This is when I would really like to use Excel because I could do this without having to do each one individually. I could just plug in the new divisor and it would like automatically do it. Okay, so notice how that rounded, I'm just going to put the rounded number. That one rounded is going to be 40, just like it was before. So I'm going to, I mean, if we do all these and they're the same numbers, we know that I have to go smaller still. So let's do B. B's population was 473,000 divided by 20,150. 23.47. If you round that, you still get 23. It's not looking good. All right, C. Oh, that was the one that was 292. 292,000 divided by 20,150. 14.49. That's still 14. Okay, so actually I know now I'm not going to get the right apportionment because I already have 3 of the same numbers, which means I can only be 1 or 2 off. I'll just finish it. So D was 594 divided by 20,150. 29.4, so that's 20. Look, they're all the same. So I didn't go small enough. $2,150. Yeah, see, they're all the same. So I'm going to get 116. So I got to go smaller. Dang it. Okay. So I don't want to keep sliding over. So I'm just going to call this, right? We see that I've done it. I'm going to do another one. So I got to go less than that. Wait, what? I did. So I'm saying, what's going on here? So my first divisor was 20,000. That was too, I got too many seats. So I had to make the divisor bigger. Okay. Then I had too few seats. So my number was too small. So I needed to make my quotas bigger, which means I had to make the divisor smaller. And I did, but that didn't do any good because making my divisor, the number I chose didn't do good enough, right? And then I made it even smaller again, but that still wasn't good enough. All right, so let's make it even smaller again. What if I use something like, whoa, that's not what I meant to do. What if I use something like, so I'm just going to keep track over here. My modified divisor 3 was 2,150. So it needs to be smaller still, because I still am not getting enough seats. Well, what about 2,050? Not 2,000, 20,050. Let's try that. So 811,000 divided by 20,050. All right, that's going to give me 40 there. I'm just writing down the rounded part. So I think in this method, did it still say, like, don't forget the decimals? You actually can forget the decimals because you're never going to use them again, right? Because you're rounding. I mean, you have to have them for the rounding, but once you round it, you're good. Okay, B, what was B's population? 473. I'm going to 23.5. Okay, that's going to give me 24. That's good. Okay, so we've got +1, right, which is what we need. And now we need +2. Two more have to increase. And one of them has to stay the same in order for this to be for this to be an appropriate allocation, right? Because we need 119 right here. That's what we're going for. And we had 116 here, so we need 3 more. So there we've got one of our 3. Okay, what's population C? That was the 292 divided by this 4th divisor, 20,050. 14.5. That goes up to 15, so that's good. There's +1. Now, as long as only one of these last 2 goes up and the other one stays the same, then we're good. All right, D's population is 594,000 divided by 20,050. 29.6. That rounds up to 30. Okay, there's our +1. So please let E stay the same. Otherwise, we have to do it another time, a 5th time. Okay, so the population here is 211. And we are dividing by our modified divisor 4, which is 20,050. 10.5. That goes up to 11. Which means that if I have been keeping track correctly, that's 119. Oh my gosh, let's see. 40 plus 24, plus 15 plus 30 plus 11. It's 1 too many. I'm so close. All right, so how far should I go up? I think I should go up to 20,100. All right, and I will slide over this time. I just don't want to. All right, so we're going to do our quotas with modified divisor 5, and I'm going to use 20,100. This better work. Okay, 811,000 divided by 20,100. 40.3, that's 40. Okay, I can't remember state B's population. That's the 473. 473,000 divided by 20,100. 23.5. That's going to go up to 24. Okay. State C is the 292. 20,100. 14.5. That goes up to 15. Oh my gosh. Don't even tell me that I'm going to have to do it a sixth time. Oh, my eye is itching. Okay. All right. D's population was 594. 594. Uh-oh. Divided by 20,100. 29.5. Okay, so that goes up to 30. E was 211,000 divided by 20,100. 10.49. Yay! That rounds to 10, and that should be 119. I will just check just to make sure. 40 plus 24 plus 15 plus 30 plus 10. Yay, 119. Okay. So there you go. So the choices that I made, right, made it so I had to calculate the quotas 5 times. Well, actually, I guess 6 times, because the first time was the regular quota, and then I did modified divisors 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 plus the first, that's 6 times. So I should have listened to my own thinking, right? The first time, you remember when I said, like, oh, 121 is closer to 119 than 116, so I should make my divisor closer to 20,000 than I should to 2,500. Didn't listen to that, went right in the middle, and didn't quite work. So if I had listened to that, maybe I would have had 1 or 2 less, but it's not that bad, right? And like I said, I could have used Excel to help me with this, and it would have gone faster just because I wouldn't have had to type in my calculator those 5 big numbers 6 times and divide by the different divisors. But this is now the final allocation using Webster's method, right? Okay, well, that was fun. So I was thinking about maybe doing Huntington Hill method on the same video, but I think I'm gonna stop here. And then I'll do Huntington Hill method on another video. So as always, if you have any questions, let me know. Hopefully I made no errors here. All right, I'll see you later.